So for problem number 13 on the practice test, we're graphing absolute value. Remember, absolute value graphs always make V-shaped graphs. So if it is a V-shaped graph, I've got absolute value, which if you notice the absolute value bars, I know I'm going to have that general shape. All right. Keep in mind the number on the inside of the absolute value bars shifts it either left or right. If I'm subtracting on the inside, it's going to shift it right. And if it's adding on the inside, it shifts it left. In this case, we are subtracting 2, so it's going to shift my vertex from the middle to the right 2. And if I add or subtract the number on the outside, if I add, it shifts it up. If I subtract, it shifts it down. I know that adding 4 on the outside is going to shift it up from there. 1, 2, 3, 4. So my vertex is actually going to be positive 2, positive 4. And all that means is that's where the V comes to a tip on my graph. So the last and final step, once I figure out where my vertex is at, is now I have to plot my other dots using the slope. And the slope is the number out front, negative 2. So if it's a negative 2, I'm going to go down 2 over 1 on each side of my vertex. And that's what's going to give me the V shape for my graph. And it's a little sloppy, I do apologize, but it is pretty difficult to draw straight lines on this when I don't have lines on the board. But that's the general form of my graph. A negative slope is going to give me an upside down looking V. The last thing I want to do is look at my domain and range. If my graph is spreading out wider and wider as you're going left and right on the graph, my domain is negative infinity to positive infinity. And then my range is my lowest y. So what's my lowest y if my graph is going down forever? Well, it's never going to reach a low point. It's going to go down forever. So I have negative infinity. And the highest point is going to be at the vertex, which is at 4. And it includes 4. So I'm going to use a bracket around the 4.